Okay, so let's start our lecture today. So, okay, last time I finished the proof that this group action as probably discontinuous and free on this xqn. Okay, so I want to show that there is a unique holomorphic structure of this quotient space xq by this relation gamma, which being defined as the declination of this current map. Okay. So yeah, which gives rise to a commutative diagram. Okay. So yeah, so I want to show. Okay, so maybe theorem. It's 5.1.6. Continue. Okay, so we show that so there is a unique holomorphic structure on this execute quotient out by the relation gamma space giving rise to a commutative diagram. Okay, so okay, so which is this is execute, and then this is the gamma projection, and then this is the x, and then this is the quotient space here. It's gamma take away x, and then this is isomorphism. Oh, sorry. Yeah. So in which this gamma of this quotient map is a holomorphic coverage map. And the map from this quotient space to this x is a biholomorphism. Okay, so yeah. Okay, so okay, so we want to show that there is a unique holomorphic structure such that giving rise to this commutative diagram, and this map from this quotient space to this x is a biholomorphism. Okay, so yeah, so let's see. Okay, so what is the so what is the actual holomorphic structure here? Okay, so we know that this x, so this x is a covering Riemann surface, right? So therefore, I think we can just define the covering map to be Oh, sorry. I think we can just define the holomorphic common map to be just you extend the map of X and then you do like yeah. Yeah, you do like the yeah, you just do the iteration by this local homomorphism, I think. Okay, so um, okay, so let's okay, so let's try to show that. Okay, so okay, so since wait. Oh, I think this is theorem that we showed, right? No. Okay, never mind. So yeah, so that okay. So now okay. So we take a atlas here. So for this x tilde, so let's call this ui tilde, and then let's call this phi I, and then let's call this ui tilde prime, and then in the wedge, yeah, so be a holomorphic atlas. Of this x tilde. Okay, so now okay, so remember we have the property that for each one we can pick an evenly covered neighborhood, right? Yeah, so basically the idea is that for each one I think we pick the wait. Okay, let me try this. So here, if I pick a point, let's say P in this X, so I can make the yes, so I pick a point P tilde upstairs, and then I just take this open neighborhood. Let's say ui tilde contains P, and then I also know that since this P is like evenly covered, right? So I can pick the I can pick the kinetic component of this. I can pick a neighborhood that. So the kinetic component contains the point P tilde. Yeah, we'll take one of the kinetic component of the pre-unit set that contains the P tilde, right? So so let's call this U here, and then this is like U. Let's call this V one of these different open set in the pre-image that contain this ubiquitous, and then okay, and then this is the UI. Okay, so you take the intersection and then that give you a open set. Okay, so yeah. So then we just replace this open set by our UI, and then everything is like phi I. Replace the phi I by this phi I restricted on the intersection, and then UI prime by tilde I prime by the restriction on the by the image map of this intersection under the phi I. Okay, so that gives you a so that gives you another holomorphic atlas. So basically for each point P, for each point you can do that, right? So and then okay, so now we've done this P to be any point in X. And then okay, so now what became okay, so what we claim is that what do we claim? Okay, so we want to give this a holomorphic structure, right? Okay, so okay, so okay. Yeah, we can take the okay, so okay, so let's call this gamma of this UI. Yeah, so we already replaced this UI by the small neighborhood that intersects with prime, right? So let's call this P. Okay, let's call this UI P. Okay. Okay. So and then we take another, let's say so let's call this UI P. Okay. And then let's say what is the map? So okay, so this phi basically is from so let's say phi I restricted on the U to the IP. Okay. Yeah. So yeah. Yeah, maybe it's better when we say this. Okay, so replace. Okay, so maybe that. Let me just add a few words. So take local holomorphic chart. That contains P2. Okay. Yeah. So now I'll just replace this one by this intersection. Okay. Okay. Yeah. Okay. So do I use the letter P? Okay. So I think I have to use a P because otherwise I want to construct. So yeah. So sorry. Let me add this P here. Okay. So this is UIP. Okay. To know that it's around P. Okay. So so now, so this is the file I compose with. Think this is gamma should on this UIP inverse. Okay, yeah, go that way, and then and then same thing. It's like this U to the IP prime. Okay. And also same thing, replace this one by the image of the intersection. Okay. And then okay, sorry. So also replace of yeah, so I'll just use this letter to indicate that it's already been replaced. Okay, so now, so I think this is a, so just take this triples. Okay, so so then we want to claim that so first we claim that so this union P of this chart, because we can pick it for every P. Okay, so yeah, so here is UIP. Okay, and divided by UIP, and then this map. Yeah, maybe I'll just use that. Is a holomorphic atlas. For this X. Okay, so so basically the idea is that, let's say if you take two intersections, right? So you take two intersections, so you want to define the so take let's say P2 is X. Okay, so now you have the map. Let's see. So what do you want? So so you want the map to be, yeah, so let's go this way, right? So, okay, so now you have that. Okay. Yeah. So you got this. So here, so this is a V. So this is okay. I just letter. I just use the letter V I Q to denote the neighborhood around Q, right? Okay. So basically, we want to show that. Okay, so okay. Okay, I think I'll just leave it to you to check. Okay, because okay. Okay, so yeah, I think so. We can show that this is a So basically, you can just take you start from the. So if you have a V and a Q, and then you start from like Q, like the Q side. Yeah, sorry. You start with the image in this you to the IQ. Okay. So basically, you take the intersection, right? So basically, you have the map. Let's say UIP, and then you have another map. Let's say so it's a point Q, and then UIQ. Then you take the intersection, and then you map it to here, and then you map it to you map it to the intersection. Let's say so here this is a replacement, right? So basically, you just map the intersection to this intersection here, and then you map this one. Let's say via the map phi distributed on this u to the IQ, right? And then, sorry, it should be a different letter for this phi, but yeah, so maybe I'll just letter VIP. Okay, so yeah, VIP, yes, yeah. So this is actually phi. So here you have the map. Let's say phi q, I think. Okay. Yeah, that being the image. Yeah, and then you map. So here you start from here, and then you want to show that it goes here, and then goes back, goes to here. It's a holomorphism. It's a back holomorphism, right? Yeah. So yeah. Yeah. So either either way they are both holomorphism. So why they are both holomorphism? Because because this will map from here to here, and then we compose it with this phi. So with this gamma, and then we compose this gamma inverse, right? So yeah, so that becomes an identity. So that just reduce the case where this is just a map between this x tilde, and then because this map between this x tilde is by definition a chart, right? It comes from the chart in this x tilde, so therefore it is a homogeneous. Okay, so yeah, so okay, so now okay, so I think so why this gamma is a holomorphic because yeah, so because wait, shoot, why is a holomorphic? I want to show that it's a holomorphic mapping between Okay, so here, okay, so why is gamma is a holomorphic map? Because if you take any chart, okay, so we want to show what? We want to show that okay, so okay, so let's see. So why this gamma is a holomorphic? Okay, so okay, so basically you take any open set, right? Or open, yeah, you take, yeah, okay. So basically the idea is that you take any chart on this X, and then what you do is that you take the, okay, so just take any open, just take any chart, okay. So that is U V. I just use the letter I, okay. So and then U tilde. So let's call this A, okay. And then okay, so why this okay, so why this gamma inverse of this UI is actually wait, gamma inverse of UI. Gamma inverse UI. Okay, so what do I want to show? So I want to show that, okay. Okay, so I want to show that it's gamma composed with is phi I. Okay, so okay. Okay, so this phi basically is this map. Okay, so yeah, so gamma composed with this phi I is exactly the yeah, so it's exactly is in this set. Okay. Basically, it's a holomorphic function on this open set. Okay. So okay, so why is the holomorphic function of this open set? Okay, so the reason is okay, so this phi I basically is exactly that you take the gamma which is on the, so this is a biholomorphism. So this is a this is a homomorphism. So therefore, you map this UI like homomorphically back to. Sorry, this is visual. We are fine. Yeah, homomorphically back to the open set upstairs, and then what you do is that you not only map it upstairs but also map it to yeah. So let me call this phi 2 then. Okay. Yeah, let's call it phi 2 then. And then you map it back to open set in this Rn or R2. Okay. So here, let's say have this one as your UI, and then this is the map. So here first you map it to the UI to and then so UI prime. Yeah. So gamma compose this. Wait. Gamma is holomorphic. Okay. Yeah. So we'll compose with this one. So actually, you are mapping this. This UI to where? So you are mapping this U. Okay, so gamma inverse of UI. Wait. Wait a second. Gamma is holomorphic. Wait, I think I messed up here. Oh, okay, okay, yeah. Okay, so okay, so I'm gonna go on the chart. Okay. Okay. So what is holomorphic? So you take a chart. Okay. Okay, so basically by our construction, right? So by our construction, this UI is actually evenly covered set. Okay. And then when we take the inverse, that gives a disjoint union of open set. Okay, and then we need to show that this is holomorphic. Okay, so Y is holomorphic. So we want to show that it's holomorphic on this disjoint union of open set. So so to show that it's holomorphic, what you need to do is that you need to take a so you need to okay, yeah. So basically, you take any holomorphic. Yes, you take any holomorphic chart, right? Okay. So Okay. So now we let uh, I think I should use the letter tilde for the upper scales. Okay, but yeah, doesn't matter. I think. Okay, let's call this V. Okay, so let's call this V here. Let's let so let me put I here. So let's call this a tilde for the holomorphic atlas of this X tilde. Okay, and then we want to show that. So we want to show. Okay, so basically, okay, so if we take any intersection of this B, of this, okay, so basically you take the intersection of B of this open set, gamma inverse of UI, and then you want to argue that if you take the, yeah, so if you take the, okay, if you take, okay. Okay, so you want to show that. Wait, what? No, it's not true. Wait. I was a little bit confused. Wait. I think here the map should be. So phi I is a chart on this X. Okay. And then okay, I messed up here. Okay, so here it should be in the other way. Yeah, so it should be. Yeah. Right. So you got gamma first. Okay. And then, okay. Yeah. So we want to show that. Phi tilde compose gamma. Composes what? Composes. Composes. Okay, so start with, okay, you start with X. Okay, start with X. Okay, so let me start. Let me start. So here this should be what? So, okay, so. Okay, so, phi composes side. Okay. So it's gamma.